When you think of global shipping, you probably picture this world of incredible precision, right? Massive ships, rigid standards. But what if I told you that its most dangerous moment is the one with almost no standards at all? Today, we're going to pull back the curtain on the last mile of a seafarer's journey, a hidden, deadly, and shockingly unregulated danger zone. Okay, let's just dive right in. What you're looking at here, this is not some random freak accident. This is a predictable outcome. It's a symptom of a much deeper problem, a total system failure that happens over and over again because the safety nets that are supposed to protect seafarers just don't connect where it matters most. So for our first section, we're going to look at this pattern of failure. Let's really dig into the scale of this problem and see just how common these supposedly rare accidents actually are. Now, what's so striking here is that this isn't happening in just one corner of the world. It is the same story, on repeat, everywhere. You've got a launch capsizing in Mozambique, a crew member falling to his death in Istanbul, a crew boat flipping on the Ohio River, another seafarer fatally crushed in Brisbane. See, these aren't isolated incidents. They're all the result of the same fundamental risks playing out in completely different environments. It's a pattern. And this quote from Captain Raghu Sharma just hits it home. For you and me, this looks like an absolutely insane high-risk moment. But for seafarers, it's just another Tuesday. This level of danger, this razor-thin margin for error, it's a familiar, almost normal part of the job. And honestly, that's the real core of the problem right there. So how exactly do these transfers go so horribly wrong? Well, that brings us to section 2, what we're calling the last mile failure. We're going to break down the precise physical mechanics of this disaster right there at the side of the ship. I mean, just look at this. This one person is shouldering all the physical risk of the entire operation. But here's the kicker. They have absolutely zero influence on how it's set up. Not on the condition of the boat, not on the skill of the operator, nothing. The responsibility is everywhere and nowhere, which leaves the most vulnerable person with no say in their own safety. So this whole failure really boils down to 3 distinct steps. First, you've got swell interaction. A tiny boat next to a giant ship is just naturally unstable. That's physics. Second, you get this thing called the interface gap, which creates a dangerous crushing zone. And third, the entire transfer literally depends on someone timing their step perfectly onto a simple ladder with no fall protection. One bad step, and it's over. Let's zero in on that interface gap because it's crucial. It's that vertical space between the bobbing little boat and the solid steel hull of the ship. As the launch gets tossed around by the waves, that gap opens and closes violently. It's a fundamental geometric problem. You can have all the procedures and checklists in the world, but they can't beat the basic physics of this crushing zone. And all of this leads to this huge, glaring contradiction, right? How can one of the most heavily regulated industries on the planet have such a massive, unregulated black hole in its safety net? That's what we're going to explore in Section 3, the enforcement paradox. It's really tempting to think, oh, we just need more rules. But that's not it. The rules exist. You've got SOLAS for ship safety, the ISM code for management, the MLC for labor rights. They all touch this operation, but they don't connect. Each set of rules governs its own little island. But the transfer itself, that happens in the dangerous, unregulated water between all of them. And this table just lays the disconnect bare. It's brilliant. On the ship side, everything is by the book, strictly regulated under international law. The ladder, the inspections, the maintenance, it's all checked and verified. But the launch side, the little spot the seafarer has to step onto, well, that's often locally regulated, if at all. It's frequently improvised, rarely inspected, and just getting eaten by corrosion. It's 2 completely different worlds of safety colliding in a high-risk zone. And the paradox just gets deeper when you look at who is being transferred. For a maritime pilot, a specialist brought on board, the transfer is a globally standardized, highly inspected, and consistent operation, every time. But for the ship's own crew on a local launch boat, forget it. There's no global standard, inspection is minimal, and the quality is totally dependent on whatever contractor the local agent picked. It's the same ship using 2 wildly different safety standards. So the big question is, why is this allowed to happen? The answer, maybe unsurprisingly, lies in the commercial realities of the shipping industry. In Section 4, we're going to talk about the root cause, delegation without control. This quote right here just nails it. The transfer of a human being from one vessel to another, a safety-critical operation, is often handled like buying pencils for the office. It's treated like procurement, a line item on a budget, a cost to be minimized. And when the main driver is saving a few bucks, safety control suddenly becomes optional. And the frustrating part is we know exactly how to do this safely. In other sectors, like offshore energy, they use purpose-built, certified vessels. They have strict weather limits, they vet and audit their contractors. But the reality for most crew changes around the world? It's the polar opposite. The job goes to the lowest bidder's utility boat, deadlines push them to operate in bad weather, and the whole thing is just delegated to a local agent. And that is the very definition of delegation without control. The ship owner hands the task to a local agent. The agent, trying to keep costs down, hires a local launch operator. The agent has zero physical skin in the game. The ship's captain has very little power to intervene, so all of the risk gets pushed onto the one person who has no power and no choice in the matter, the seafarer. Okay, we've laid out the problem pretty clearly, so now let's talk about the solution. In our final section, we'll look at how we can and should close this critical safety gap. This might be the most important slide of all. On the left, you see the problem, a conventional launch capsized. On the right, you see the solution, a modern, purpose-built crew transfer vessel, or CTV. It's a stable catamaran design built specifically for this exact job. The technology to fix this isn't some far-off dream. It exists, and it's used all the time in other sectors. So let's be really, really clear on this. This is not a technology problem. It is not a knowledge problem. We know the risks, we have the solution. What's missing is the will to create and apply a single enforceable global standard for this last mile. We demand global standards for the entire voyage. It's insane that we don't demand it for the boarding. And what would a standard like that even look like? Well, it's pretty simple. It rests on 4 key pillars. First, you mandate purpose-built vessels. Second, you have universal rules for safety gear. Third, you create standardized certification for the people operating the launches. And finally, maybe most importantly, you create a single point of unified accountability that connects the dots from the shore office all the way to the ship's rail. So, we'll leave you with this question. In an industry that has absolutely mastered the mind-boggling logistics of moving trillions of dollars of cargo across oceans with incredible precision, why is the most critical and final step, getting its own people safely to and from their workplace, so often just left completely to chance?